Continuity of a function at a point. In this module, you will learn about the continuity of a function at a point. We already know how to draw the graph of a function. When we can draw the graph of a function without lifting the pencil from the plane of paper, the function is called a continuous function. Otherwise, it is called a discontinuous function. These definitions give us an intuitive idea of continuous and discontinuous functions. For an exact definition of continuous functions, we use the concept of limits. Look at this function. If we draw its graph, we get a continuous function. Let's now look at some features of this function. This function is defined for all real values of x. If we take any point, say 2, on the x-axis, the value of the function at that point and the nearby points is the same. The nearby points may lie to the left or right of the two. So, we have the left and right hand limits of f at 2 equal to 3. Since the left and right hand limits of f at 2 coincide, we can say that the limit of the function at x equal to 2 is 3. Also, the value of the function at 2 is 3. That coincides with the limit of the function at 2. Similarly, if we take any other value of x, we see that the value of the function at that point coincides with the limit of f at that point. So, this function is continuous for all real values of x. Let's look at some features of this function. The function is defined for all real values of x, except for 0. If we take any point on the x-axis, the value of the function at that point and the nearby points is the same. If we take 0 on the x-axis, the value of the function at 0 and the nearby points to its left is 1. In contrast, the value of the function at the nearby points to the right of 0 is 2. Using the concept of limits, we have the left-hand limit of f at 0 as 1 and the right-hand limit of f at 0 as 2. Also, the value of the function at 0 is 1. That coincides with only the left-hand limit. So this function is discontinuous at x equal to 0. This discussion helps us to conclude that a function is continuous at a point only if the function is defined at that point and the value of the function equals the limit of the function at that point. In this module, you have learned a function is continuous at a fixed point if we can draw the graph of that function around that point without lifting the pen from the plane of the paper. Otherwise, it is discontinuous. A function is continuous at a point, say x equal to c, if the function is defined at x equal to c, the limit of the function equals the value of the function at x equal to c.